Hello everyone, this is Vaishnavi from JNTU. Today I am going to share with you about closed hashing as a subtopic in collision resolution techniques of data structures. This video is done as an assignment given by K. Somsena Reddy sir of JNTU. The topic is collision resolution techniques. In that subtopic is closed hashing. Firstly, we know about what is hashing. Hashing in the data structure is a technique of mapping a large amount of data into small tables using a hashing function. What is collision resolution technique in hashing again? Here we face in the process of hashing collision problem. To reduce this collision problem, we have some techniques. Those techniques we are going to study on this in this video. The first question is what is collision resolution technique in hashing? When two items hash in the same slot, we must have a systematic method for placing the second item in the hash table. That means if the single place in the hash table is allocated to, we cannot allocate that only single place for two elements. For that problem, we have some techniques. The process is called collision resolution technique. There are several strategies for collision resolution, but mainly they are divided into two types: separate chaining and closed hashing. Separate chaining is also known as open hashing, and closed hashing is also known as open addressing. Open addressing is again subdivided into three types. They are linear probing, quadratic probing, double hashing. This is a tree diagram of types of collision resolution techniques. There are many, but these are the main. Define separate chaining. Separate chaining technique combines a linked list with a hash table in order to resolve the collision. This is the definition of separate chaining. Separate chaining is a strategy. A separate list of all elements mapped to the same value is maintained. Separate chaining is based on collision avoidance. To avoid collision, we use this separate chaining technique. If memory space is tight, separate chaining should be avoided. That means if memory space is free, separate chaining can be used. Additional memory space for links is wasted in storing address of linked elements. Define open addressing. That is, open addressing is also known as closed hashing. As we said above, separate chaining is also known as open hashing and open addressing is also known as closed hashing. Now we can know about the definition of open addressing. The main idea of open addressing is to keep all the data in the same table. To achieve it, we search for alternative slots in the hash table until it is found. Open addressing. Separate chaining requires additional memory space for pointers. Open addressing hashing is an alternate method of handling collision. First method is separate chaining and alternate method we have is open addressing resol- for resolution as collision. In open addressing, if a collision occurs, alternate cells are tried until an empty cell is found. The main difference between open hashing and closed hashing is in open hashing the collision is resolved by adding another element at same location, whereas in closed hashing it is in open it is the collision is resolved by adding another element at a different location. Open hashing it is location is same, but in closed hashing it is at different location. We have three types: linear probing, quadratic probing, double hashing. We saw here there are three. Open addressing is subdivided into linear probing, quadratic probing, double hashing. Let we see about linear probing first. In linear probing, whenever there is a collision, Cells are searched sequentially for an empty cell. Sequentially, that means one by one. With wraparound, that means one by one. For an empty cell, let hash of x be the slot index computed by using a hash function and s be the table size. Here, if slot hash of x mod s is full, s here indicates table size, hash of x mod s is full, then we try hash of x plus 1 mod s. This is the formula. If hash of x plus 1 mod s is also full, then we try hash of x plus 2 mod s. If hash of x plus 2 mod s is also full, then we try hash of x plus 3 mod s. This process is repeated continuously for all the values of I until an empty slot is found. Here I means 1, 2, 3, so on. It can be increased until the empty slot is found. Here is an example for linear probing. Figure shows the result of inserting keys. Key elements are 9, 7, 11, 13, 12, 8. Using the hash function f of key is equals to key mod 6 and linear probing strategy. Here, firstly we have to draw a table that indicates index and key elements. Index values are here 0 to 5 because there are 6 elements. So, indexing should be start from 0. Let table size be here 6. It can be 7, 8, 9, 10, so on. But it should not be less than 6 because we have the elements are here 6 elements. The table size should not be less than the number of elements. So step 1, first key to be inserted in the hash table is 9. First key we have here is 9. We have the formula key mod table size. Key element is 9 here, mod table size is 6 here. So key mod table size 9 mod 6 is 3. So 9 is inserted at the index 3. Next we have 7. Next key to be inserted in hash table is 7, second element. So 7 mod 6, that is key mod table size 7 mod 6 is 1. In the index number 1, the key element 7 is inserted. Now key to be inserted in the hash table is 11. 11 mod 6 is equals to 5. So the key will be inserted at the index 5 of the hash table. 11 is inserted in the key index of 5. The 11 element is inserted. Step 4. The next key element we have is 13. 13 mod 6 is 1. But here we saw the collision here. Collision is occurred here. That is in index 1 already the key element 7 is inserted. We saw before. Here index 1 is already filled now. Right. So check for next position. That is 13 plus 1. Here I is 1. 13 plus 1, that is 14 mod 6 is we get 2. Here 2 index 2 is empty. So 13 can be inserted in index 2. Next step. We have the element 12 here. 12 mod 6 is 0, right? 0 in index 0, there is no element before. So now we have inserted the element 12 in the index 0. Next step, we have the element as 8. 8 mod 6 is 2. Here index 2 is already filled. We have filled the index 2 with the 13th the element 13 as key element. So next position can be checked. So 8 plus 1 mod 6 is 3. 9 mod 6 is 3. Here the index 3 is also filled. So check for next position. In index 3, we have 9. 8 plus 2, that is I here is 1, the next I here is 2. 8 plus 2 mod 6 is 4. 10 mod 6 is 4. In the fourth index, there is no element. So 4 is empty. So key will be inserted at the index 4 of the hash table. Next, we have quadratic probing. In quadratic probing, whenever there is a collision where we look for the I squared slot in the ith iteration of in the hash table. Let hash of x be the slot index computed using a hash function and capital S be the table size here as usual before. If the slot hash of x mod s is full, that is, then we try for hash of x plus 1 into 1 mod s. As I is increased before to 1, 2, 3 as well as here also I here is increased to 1, 2, 3 if it is full. If hash of x plus 2 into 2 mod 7 is also full. This process is repeated for all the values of I until an empty slot is found. Here is an example for quadratic probing. Figure shows the results of inserting keys 50, 700, 76, 85, 92. These are the key elements given using the hash function f of key is equals to key mod 7 and quadratic probing strategy. Let table size be 7 here. First key we have here is 50. 50 can be inserted in the index 1 by using the formula 50 mod 7 is 1. Key mod table size is 1. In the index 1 there is no element, then we can insert 50 as usual. Insert second element 700. With the table size 700 mod 7, the table size 700 is mod 7 is we get 0. In index 0, element 700 can be inserted. Third element we have is 76. 76 mod 7 is 6. So key will be inserted at the index of 6 of the hash table. Next, fourth element we have here is 85. 85 mod 7 is 1. Here collision occurs. The position 1 is already occupied. So by using the quadratic probing technique, we have the formula given as hash of x plus I into 1, that is 1 into 1, I here is 1, mod 7 is 2. So key will be inserted at the index of 2 of the hash table. Insert the fifth element. We have the fifth element as 92. 92 mod 7 is 1. In already index 1 there is 50. So here also collision occurs. The position 1 is already occupied. So by using the quadratic probing technique, that is the formula hash of x plus 1 into 1 mod of 7 is 2. We get 2, but here 2 is also filled with the other element that is right before element 85. So we have to move for next. Hash of x plus 2 into 2 mod 7, that is hash of x plus is 1. 1 plus 2 into 2, that is 4. 5 mod 7 is 5. So key will be inserted at the index of 5 in the hash table. Double hashing. It works by using two hash functions to compute two different hash values for a given key. The first hash function is used to compute the initial hash value and the second hash function is used to compute the step size for the probing sequence. Double hashing can be done using hash 1 key plus I into hash 2 key mod table size. Here hash 1 and hash 2 are hash functions and table size is size of the table, hash table. A good second hash function is it must never evaluate to 0 and just to make sure that all cells be probed. We have an example for double hashing here, that is insert the keys 79, 69, 98, 72, 14 into the hash table of size 12. Resolve all collisions using double hashing where first hash function is h1 of k is k mod 12 and second hash function is h2 of k is equals to 1 mod sorry h2 of k is equals to 1 plus k mod 11. Here in the question itself they given the table size as 12, whereas we saw before there is no table size given in the question, so we have assumed as number of elements, I said before number of elements should be greater than table size should be greater than number of elements. Let table size given here is 12. So first key to be inserted in the hash table is 79. 79 mod of 12 is 7. So in index 7 we can insert 79 happily. First key to be inserted in the hash table is 69. 69 mod 12 is 9. In the index 9 there is no element, so we can insert 69 happily. Next we have the 98. 98 mod of 12 is we get 2. In index 2 98 can be inserted. Next 72 we have. 72 mod 12 is 0. In index 0 72 element is can be inserted. Next we have 14 as the last element. 14 mod 12 is 2. Here index 2 is already filled with the number 98. So go for the next position. By using double hashing technique, that is the formula h1 of 14 plus I into h2 of 14, that is hash function 1 plus I into hash function 2 modulo of 12, we get here first hash function 14 is 2 and here I can be replaced with 1. Hash function 2 of 14 can be used as 1 plus k modulo of 11. This modulo of 12 is we get as 6. So the key is inserted at 6th position. Whereas 6th position is empty before. So 14 can be inserted happily. I hope you all understood. Thank you.